In this video we're going to explore correlation. Now correlation is a relationship between two variables. Just because we say there's a relationship doesn't mean that one causes the other to occur. There's just something going on that causes there to be that relationship. Often we write these as ordered pairs, where our x value in the ordered pair represents the independent variable and y represents the dependent variable. Now there's primarily a couple different ways we can look at this graphically. We say there's a positive linear correlation if as the x values increase, the y values increase, so you get that positive slope if you drew a line. We say it's a negative linear correlation if as the x's increase, the y values decrease, so you'd have like a negative slope if you drew a line. And then we say there's no correlation if the values are all over the place, so there doesn't seem to be any type of reason how those points are related to one another. Or we could also say there's a nonlinear correlation if we're going to put an underlying function on it and it is not linear. Like this one looks more parabolic. Now when we talk about our correlation coefficient, it's important to recognize that we're talking about the strength and the direction of the linear relationship between the two variables. If we're talking about the population's coefficient, we use the symbol rho. Looks like a fancy P. And if we're talking about the sample correlation coefficient, we use R. And that's what you're going to use probably more than anything, because most of the time we are dealing with samples. Our correlation coefficients must always fall between -1 and +1. The closer it is to -1, the more negative that relationship is, and the closer it is to +1, the stronger the positive relationship is. If you have a correlation that's almost at 0, that is saying that there's no actual correlation, no relationship between your independent and your dependent components. When we talk about the strength of a correlation, if you're between 0 and 0.5, we consider that weak. And the closer you are to 0, you can pretty much say that it's no correlation. When you go from 0.5 to 0.8, that's considered moderate. And then you're considered to have a strong correlation if you're between 0.8 and 1. And if you notice, there's these vertical bars, and those are absolute values. So if I were to say -0.85 or +0.85, the strength is the same. The difference is one's negative, a strong negative relationship, and the other's a strong positive relationship. So the strength has to deal with how close it is to -1 or 1. Now, if you want to actually create your scatter plot, we can use Excel to help us do this. We put our data into two columns. The easiest is to put the x values in the left column and the y values in the right column. And then we're going to go through, highlight the data, and insert a scatter plot. Now, the easiest way to lay out your data so you can put your charts and put your titles and everything is to go under Chart Tools, do Design, and then choose Layout 1 from the chart layouts. I always remove the Series 1 that you'll see that comes up. It's a little kind of like a key. I delete that out, and then I label my axis, and I'll give it a title as well. Now here's the important thing. If you want to be able to know what is the correlation for your data, we use this Excel function called correl, where we then highlight the x values, put a comma, highlight the y values, put a comma, and then it'll shoot it out directly for us. And then we use that to tell us, is it weak, moderate, or strong, and then we also label the direction, positive or negative. So let's look at an example here. Say in this study we see if there's a correlation between men's height and weight. And we use the data below, find the scatter plot and the correlations. So I take my data, I put it into Excel, and this is the graph that I end up creating with my scatter plot. And if I look, it looks like there might be a positive trend with the data here, but let's actually run the correlation function and see what happens. And so I do correl, I'd highlight my x's, which is my height, comma, highlight my y's, which is my weight, and I'd get 0.783. So if I look back at my options of weak, moderate, and strong, that would be a moderate correlation. So what we would say is there appears to be a moderate positive relationship between men's height and men's weight. And this correlation function will also shoot out whether it is positive or negative, which is a nice feature. Now you can also do hypothesis testing for population correlation coefficients. The biggest difference you have to pay attention to is that instead of the n-1 degrees of freedom we've used for other hypothesis tests, such as your standard deviation and for your t-test, in this case we actually use n-2 degrees of freedom. So make sure you pay attention to that. And when we do correlation coefficient testing, we are using a t-test. Just make sure your degrees of freedom are n-2. The claim will always be in the alternative because you're going to test and say, is there a negative correlation? And then this will be your test, and your claim would be on the alternative, that it's less than 0. If it was positive, this would be your null and your alternative hypothesis, and again, the claim would be on the alternative. And then if it just asks you, is there a relationship, I would use the equals and not equals, again with the claim being on the alternative. So the steps we follow are just like what we've done with other hypothesis testing. We're going to state our claim, we're going to state the null and alternative hypothesis, we're going to make sure we recognize what are our alpha and what is our degrees of freedom. We sketch the t-distribution, we find our critical values, and we're going to create that rejection region based on the alpha on the graph. And then to find the t-statistic for our r value, we use this formula here. And we just plug in the correlation coefficient we find, and we do our sample size -2. So let's look at that example again of men's height and weight. So if this one says it wants me to do a significant positive correlation, that's what we're looking at. Is there a significant positive correlation at 0.05? So if I'm doing that, I know that I'm looking at that first option, the second option, which is where rho is greater than 0. And that's where the claim is, because the claim is always in the alternative. So I'm looking at a right-tailed test. So to do that, I'm going to use the formula. I'm going to take 1 minus my alpha value, and then I'm going to do sample size -2. Gives me a t-value of 1.812. So I would know that I have 1.812 here, and I shade to the right. And I'm going to see, am I aligned within the rejection region? Now I found that my correlation coefficient was 0.783, so I'm going to plug that into the t-statistic formula that I have. Plug in the 0.783 and simplify, and I get 3.981. So that's way over here. So that is definitely in the rejection region. So the way I would write that is at the 5% level of significance, there is sufficient evidence to support the claim that there is a significant, moderate positive relationship between men's height and weight.